This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters Program. Friends, we are going through with Advanced Hive and in our previous session, we have gone through with the partitioning. Partitioning that is working onto the principle dividing the data into the smaller chunks so that the scanning can be reduced. Another aspect from the partitioning side, it is working onto the column which is having low cardinality. Partitioning is applied where we are having low cardinality, and it is of two type, static and dynamic. And we have gone through with certain examples, and practically we have implemented uh, partitioning. So this particular optimization technique that is going to utilize the amount of scanned data is coming inside the optimization which is applied while creation of the tables. So over here we are creating certain tables, and while creating tables we are going to apply this particular optimization, and we are able to see that it is going to put the data inside the HDFS into different directories or folders, and with respect to that particular folder structure we are able to minimize the amount of scanning. So that is with respect to partitioning. Now inside the category optimization during creation of table, one another technique is there, that is bucketization. So bucketization, what I can say, bucket. Okay, so once we are talking about buckets, the very first thing that will come in our mind, it is applied on the tables or the column where we are having high cardinality. Yeah, it is applied on column where we are having high cardinality. That is, we are having multiple elements inside the column based upon what we are trying to do the chunking. Based upon that we are trying to split the data. Okay, so it is applied where we are having high cardinality, and once we are talking, and it is working onto the same principle, working on same principle, that is divide the data into smaller chunks so that amount of scanning can be reduced. Okay, so that is nothing but bucket. Now once we were talking about the partitioning, there were certain steps, like we are creating the tables, normal tables, then we are going to dump the data, and then we are creating the bucket partition table, and then we are dumping the data from normal to the partition table. So in the same fashion we will be going to implement bucketization now. So steps involved in bucketization. So we are having 4 to 5 steps over here. Number one, creation of non-bucket table. Non-bucket table. Then insert the data or load the data into non-bucket table. That is nothing but the normal table, what I can say. Third one is creation of bucket table. Then fourth one, loading the data from non-bucket to bucketed table. Bucket table. And fifth one is scan the data from bucketed table. Okay, so these are the 5 steps that we are going to perform in order to get the understanding about the bucketization. So in order to get the understanding about bucketization, let me walk you through with the data set what I'm having. So let me close this and share folder. Okay, Hive data set. New products. Just have a look over here. Okay, so we are having certain data, like say one, it is having certain uh, columns, or with say over here, what I can say, this is the ID. Okay, this is, or you can say this is nothing but products CSV, and it is having the product information. So this is the ID of the product, this is the name of the product, okay, like iPhone, doll, Galaxy, okay, Nokia, Y, truck, okay. So this is nothing but the name of the product, and then cost of the product, and then last one is nothing but the category of the product. So based upon this particular data set, although like this is the small data, but in order to get you the understanding, in order to provide you the understanding about the bucketization, this will playing a good role. So you will be able to get the understanding. So over here, friends, there are certain columns. So first one is the ID column, what I can say, product ID. Product ID. And last one is nothing but the category. So which one is having high cardinality? If I'm talking about this product.csv, which one is having high cardinality? Which column is having high cardinality?
First one.
First one is having high cardinality, and the last one, that is the category what I have mentioned, so this is having low cardinality. And the thumb rule, what it is saying, if we are having high cardinality, then we must proceed with bucketization. And if we are having low cardinality, like less number of elements inside the column, which based upon what we are trying to perform the query. Okay, so this particular column is having low cardinality, and this one is having high cardinality. So let's proceed further. First we are going to create the schema. First we are going to create the table, and then we will dump this particular data into that particular table. Then we will create the bucketed table and dump the data into the bucketed table from the normal table. Okay, so just have a look. This is, let me open it, because we need to create the schema based upon this only. Okay, perfect. So I'm going to pick this particular line, creation of a non-bucketed table. So create table, and I can give, so this is the normal table basically. This is not having any bucket. So what I can mention, this is the products normal table. Products, or what I can say, non bucket products. So this is the products table what I'm going to create, and first one is the product id, and this product id is of integer type, that is fine. Then what we are having, we are having the name of the product, and that is of string type. Then what we are having, we are having cost, and then category. Cost, that is of say double type, and then what we are having category, category that is of string type. Okay, perfect. So this is the schema of this particular table, and row format delimited, fields, this is the CSV file, so fields terminated by comma. Okay, so this is the normal table or non-bucket table, non-bucket products table, and I'm going to create this. This is the Hive terminal. Okay, and let me paste it over here, and the table has been created. So products, non-bucket products. So this is the table what I have created. That is fine. Now what I'm going to do, I'm going to load the data into this particular table. That is the second step with respect to the bucketization. Load the data into the non-bucket table. So that is pretty simple. Load data. What do we need to mention if we are going to load the data from local?
local in path.
Local in path. We need to mention the path into table. What? Table products, non-bucket products. And we just need to copy this particular path. Mhm. So this is the path, and from this particular path we need to load the data into the non-bucket products table. Let me copy this and paste it over here onto the Hive terminal. Okay, perfect. So select star from non-bucket products. Okay, so we are able to see that the data is loaded into this particular table. Just have a look. So this is the ID, this is the
Ashok,
product
Ashok,
name. Mm-hmm.
Ashok, you
Yes,
zoom
yes.
out here, you zoom out here, this table, okay, and it come in the good visibility. But in my case, what I am doing now, after zoom out, the format seems not good. Is there any shortcut key you are using after the zoom out?
Yes, 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 yes.
What
So
is the key?
try to like to increase the font size, control shift and plus. Okay, and to decrease the size, control minus. Right, control minus to decrease the size. Okay, and control shift plus, that is to
No, no.
increase the size.
I'm doing the same. I don't know when I did na control minus and all, but I don't know
Mm-hmm.
what happened with my case. I'm not able to see the header is very good way. Like,
Header,
yeah.
probably you are using Hive, not Hive 2.
Okay, I will discuss later this offline.
Okay, you are using Hive. In
No,
Hive
no.
2, that is beeline basically.
I'm using Hive too, but I will show you later. Huh? I'm using the
Okay,
Hive
okay,
too. I don't know what is the. Yeah.
okay. We will have discussion. No need to worry. Or guys, try to utilize that Slack channel. So try to paste. the issues whatever you are facing, let me show you. So we are having the Slack community. Okay, so what you can do, you can go onto your Slack, open your Slack, and we are having different channels inside the Slack, right? So what you need to do, you just copy and paste the stuff, huh? So we are having, say, Hive, you are facing issues with Hive, huh? So what you need to do, like you can copy this particular stuff, you can take the snapshot and all whatever you want, you can paste your query over here. Okay, if you want you can paste the code as well. Message, you can put your message over here that I'm getting this particular issue, and it will be saved as a thread, huh? If anybody else who is facing the same challenge, based upon that particular thread he will be able to get the solution, huh? It is not like you are the only one who has faced this particular issue, right? So try to utilize these particular channels, that is these channels are, or threads are prepared in order to give you the liberty to utilize these particular tools. Okay, so just click, like say we have opened the generative AI as well. So if you are having certain doubt or queries with respect to the generative AI, gen AI, so you can paste your query over here. If you are having Hive related issues, okay, say uh, bucketization is not working for me, okay, and if you are having certain code you can paste the code as well.
I think I'm not able to send message on this booster and
No,
all.
no, no, all of you will be able to send the message, huh? Shift plus C, huh? Okay, so you can paste your code and all whatever you are having, if you are having any challenge and all. Okay, so this particular, you can, this is the good platform where you can discuss about your problems and you can get this the solution, even like some of your friend like who is in this particular community will be able to respond, if like you are not able to get the things, then definitely I will be able to see your queries and I will be able to reply on that, say like Mukesh has joined, so I will be able to see the queries from each one of you. Okay, if you want to send the personal message, so we are having this particular link, like I will be able to send the direct message, okay, so try to utilize this particular platform in order to solve your queries, in order to clear your doubts, this is a good one, and all the, you can say, big organizations are using this particular platform. If a particular new product is coming in any organization, then they are going to open a Slack community, and with respect to that particular product, all the queries are and doubts are coming over there, and then a dedicated team is assigned in order to solve those particular doubts and issues, whatever. Okay, so this is a good community in order to like to move, or that will be a step to move towards the data engineering, actual data engineering, so try to utilize this particular platform, right? Okay, and we will discuss like why you are not uh, getting the outcome in the required format, right? So let's proceed further. So this is nothing but the data into the non bucket products table, Okay, and let me mention describe formatted non bucket products. Okay, non bucket products. Table not found products. Hmm. We use bucket. Spelling mistake. Okay. So what I want to show you, this is nothing but the manage table, right? And manage table, and once we have created the partition table, we were having the information that this is the partition table and partition table. So this is the normal table, and we are not having the partition related clause over here. Once we are going to create the bucket table, then we will be having certain information with respect to the bucketization and all, right? So this is the description about this particular table. Like over here, bucket column, it is nothing, like bucketization is not performed over here. Okay, so bucket information is not there. Once we are going to implement the bucketization, then we will be having that particular information. So this is the normal table, and with respect to the first two steps, we are okay. And now we will move ahead with respect to the third step, that is creation of the bucket table. So creation of the bucket table, what we need to do, we just need to copy this particular schema and paste it over here. And what we need to do, we need to do the change, like creation of the bucketed products table. Okay, create table bucket products, product ID, that is fine, name, cost, category, that is fine. We need to add a clause over here, that is clustered by, clustered by, clustered by what, which one is the high cardinality column? Product ID, product ID. Guys, are you with me? Into,
Yes, Ashok.
okay, so we just need to add one clause, clustered by product ID. Okay, because this is the high cardinality column, clustered by product ID. Now friends, we need to decide how many buckets you want. Okay, and what I have mentioned in our previous session, that it will come with experience, like what is the exact number, or what is the exact amount, what is the total number of buckets, what are the total number of buckets that we need to define. That will come with experience. You need to do certain benchmarking, you need to have the understanding about the data set, like how many records are there, what is the cluster configuration and all. So based upon that understanding, that particular knowledge will come. But over here, as a developer, as an architect, we need to decide the number of buckets, so over here we are having how many records? Okay, say 11 records are there, so we can uh, have 4 buckets, 3 buckets. Let me mention, say 3 buckets I want. Okay, clustered into 3 buckets, 3 buckets. Row format delimited, fields terminated by comma, that is perfectly fine. And this is the clause what we need to add in order to have the bucketization into this particular column, into this particular table. Now, I just want to show you something. Yesterday we have discussed about the partitioning. So there is a difference between partitioning and bucketization. So once we are performing partitioning, so the column based upon what we are going to perform the partitioning, it will not be the part of this particular definition. Okay, so say state, we need to perform the partitioning based upon state, so state column will come out from here and it will be mentioned over here. But that is not the case, my friends, with respect to the bucketization. If we are going to perform the part bucketization based upon the products column, okay, product id column, so it will be mentioned over here as well in this particular inner uh, uh, definition, and it will be mentioned over here. Okay, so this is a fundamental difference between the bucketization, like the way how we are going to create tables, partition table and bucketization table. So this is the fundamental difference. This particular clause will have the definition, okay, and it will be there inside the inner definition as well, and it will be available inside the bucket clause. So clustered by product ID into 3 buckets, 4 buckets, 10 buckets, whatever you want to have, you can have that much bucket over here. But once we were creating the partitioning table, we just need to mention partitioned by this. That is perfectly fine, and it will be that particular column will not be the part of this particular definition. You just focus onto the cursor. So perfectly fine. This is the definition how to create a bucketed table, and let me paste it over here, and the table has been created. So show tables. Okay, and what we are able to see, non-bucket bucketed table. So bucketed underscore products, this particular table has been created. We are moving as per our steps. Okay, so the fourth step is loading the data from non-bucketed table to bucketed table. That is the step number 4. So let's move further in order to load the data. And how we will be able to move, so from from which table, from this particular table, non-bucketed products, from non-bucketed table, non-bucketed products, insert into table, of which table, the bucketed table, bucketed products table. Okay, then what we need to insert, say select product ID, then name, then cost and category. Okay, I'm like moving with respect to the different way what we have done in our previous session. So this is one way, like how you will be able to move the records from one table to another table. So from non-bucketed products, insert into table bucketed products, select the product ID, name, cost and category. So let me try to, and what you need to do, you need to like Google, like how to load the data from one table to another table, and you need to identify another approach, and you can take that particular stuff as an assignment. So I'm showing you one way how to insert the record from one table to another table. Okay, you need to identify the another format, another uh, method in order to load the data. Okay, so let me paste it over here and copy. So like the query is executed, is being executed, and it will take couple of seconds, and then we will be able to see the movement of data from one table to another table. Okay, so before moving further, let me show you what is implemented into the HDFS. So batch 32, this is the database what we are having, and it is available as a directory. We are inside the batch 32, that is the database inside the Hive. And over here we are having a non-bucketed table and the bucketed table. So so non-bucketed products, this is the normal table, and over here what we are having, new product CSV. And if someone is willing to have the data from this particular file, so we need to scan the entire records from here. So scanning will take time, but just have a look what has happened once we are talking about the bucketed products. So over here what we are having, this is not as per our expectation. Let me download this. Okay. Now tell me, is bucktization implemented over here? You need to tell me. What is your expectation over here with respect to the theory? What we have seen, what we have covered. We are having single file over here. Okay, and let me try to load this particular data, and you need to answer, is it the right stuff what we are able to see over here? These are the total number of records over here in this particular partition. So is it the correct one? Is it the correct one what we are able to get?
No,
No.
no,
So it's something that I need to discuss. Okay, so who is saying no? Vikas.
yes,
Okay, Vikas is saying no. Pankaj, what about you? We are able to get all the
No.
records in one file. No, right?
Yes, yes, yes.
Rohit, Rohit, what about you? Is it implemented in a good way? Is it implemented? Is it implemented correctly? Yes or no? Rohit, I'm not able to hear. Okay, probably like some mic related issues are there. Gaurav, what about you? We are able to see all the records in one file. So is it correct or
Hello. I'm audible now.
yes, yes, Rohit.
Yeah. As per theory, I think we should be having three files.
Right. We must have three files, but we are able to see the records in one file only. Although, like, there is no any error. the command has been executed successfully. Yeah. Okay. There is no error. We are able to see like the execution has been done, and the movement of records is also happened, but the bucketization is not working. Okay. So we have mentioned three buckets, but we are able to see single file only, right? Mukesh and Naresh.
Yes.
Yes, sir. Yes.
Okay, so we must have three files because bucketization is going to create file inside the HDFS path. But what we are able to see, we are able to see single file only. So that is not as per our expectation. And why it is not working? Because we need to set one property before implementing the bucketization. And what is that particular property? So this particular property is set hive dot enforce dot bucketing equal to true. Okay, so we need to set this particular property before applying the bucketization, and then we will be able to see the buckets. So set this particular
Mm,
property.
By default, this is false.
This is false. We will see. Okay,
Oh, okay. Okay.
so just let me check. Let me check the value. Okay, so by default this is false, right?
Yes, yes,
Yeah.
yes, sir.
Got it.
Okay,
Yes, yes.
so we need to set this particular property, set this property before implementing the bucketization. This is very important, and because of this particular reason, by default this is false, because this is false. So we are not able to see bucketization. We are not able to see buckets. How to check the value of this property? Okay, so let me set this first of all. What I'm going to do, I'm going to drop bucketed table, bucketed products. So table has been dropped, that is perfectly fine. Now I'm going to set this particular property, and let me check the value. It's set to true. And now what I'm going to do, I'm going to create the non-bucket the bucketed table. I'm moving with the steps what we have implemented, and now I will load the data into this particular table. Same command I'm going to run over here, and then post execution of this particular command, we will see the directory structure inside the HDFS. Okay, so the execution has been done, and let's validate the stuff inside the HDFS. Okay, so we will be having the bucketed products, and just have a look, my friends. Now we are having three files over here, and we know it very well. Bucket is going to create a file. So if we have three buckets, then three files will be created. Okay, and based upon the internal function, the movement of records will happen, and we will be having the records and distributed records in these particular buckets. Now just have a look. So over here at this moment, like uh, 3, 6 and 9, these are the records into this particular table, sorry, a file. So certain like modulus division is working. So we have three buckets. So one percentage division, modulus division 3. So it will move to say bucket 1, bucket 1, 2, modulus division 3. So it will move to bucket 1, bucket 2, sorry, bucket 2, and 3 percentage division 3. So it will move to say bucket 0, bucket 0. Okay, so we have seen in this particular fashion 3 and 6 and 9. Okay, 3, 6 and 9. So these particular records will move to the bucket 0, right? Are you with me? 3 will move to the bucket 0,
Yes, yes, Ashok. Clear.
6 will move to the bucket 0, and 9 will move to the bucket 0. And just have a look what we are able to see. 3, 6 and 9. Okay, 3 is nothing ID. 6, 9. And this is nothing but the bucket 0. Okay, so bucket 0, 0, 1 and 2. If I'm going to open 2, so what will happen with respect to the bucket 2? So for percentage division 3, so it will move to the bucket 1, bucket 1, 5 percentage division 3. Okay, and it will move to where? The bucket 2, then bucket 2, then 7 is there, 7, then it will move to the bucket 1, 8 will move to the bucket 2. Okay, 9, 10, 10 will move to the bucket 1, and 11 will move to the bucket 2. Okay, so 2, 5, 8 and 11, these four records will be there inside the bucket 2. So just have a look onto the bucket 2. Bucket 2. Okay, this is bucket 2. Let me download. Okay, and perfectly fine. 2, 5, 8 and 11. 2, 5, 8 and 11. And what we are able to see over here? 2, 5, 8 and 11. So the modulus division function is working perfectly. What we are able to see, it is deciding which record is moving to which bucket. Okay, That is important. Huh?
Ashok, how it will be decided that first record will go to bucket 1?
Okay, so one product ID one, we are having this particular data. We are having this particular data. So it is going to pick product ID one. It is going to divide it with the number of buckets. That is modulus division. Okay, 3% is modulus division, 1% modulus 1 modulus division 3. So remainder will be 1, right?
Okay, that's why it goes to it is going to bucket 1, eh?
Yes, it is going to bucket 1. 2 modulus division 3, so the remainder will be 2. It is going it is moving to the bucket 2. 3 modulus division 3. Okay, so the remainder is 0 over here.
Okay, got it.
Okay,
Yes,
so
yes.
in this particular way the records are moving in a desired bucket, and we are having this particular information. We have gone through multiple time with respect to this particular calculation, and we have validated it as well. So in this particular way the records are moving to a particular bucket, right? So this is nothing but the bucketization, and this is very important with respect to the bucketizations. Once you are trying to implement the bucketization, then you need to set this particular property to true. Set hive dot enforce dot bucketing. So you need to set this particular property to true. By default it is false. Okay, and be strict to the concept that you have learned. So with respect to our concepts, what we were expecting, we need to have three files. Bucketization is going to create a file. If we are having 5 buckets, then five files must be available inside the SDFS path, but that was not available. So it means somewhere something has happened wrong. So then we like try to proceed further in order to check like what else is required, and I was having the awareness that we need to set this particular property. I have
Ashok,
captured these.
this is one
Mhm.
time activity, na, to set it true.
With respect to a particular session. Okay, if you
Okay,
log out. Okay, if you log
then
out.
again, we have
Yes,
to set it true. Okay,
yes. Okay.
okay, okay.
Right,
So,
and I have mentioned these particular details inside the slide pack as well. Okay, and I will be sharing these particular slides with you all. So just have a look over here. So dynamic table, that is nothing but dynamic partitioning related stuff. And over here, loading the data. This is with respect to the partitioning. Now the bucketization. So with respect to the bucketization, we need to set this particular property. Right, and once you are going to set the property, then the bucketization will work for you, right? Okay,
So,
fine so far.
hello,
Yes.
hello,
yes,
hello.
yes, Ashok.
Okay, now this is fine that we are able to do the partitioning, and we are able to perform the bucketization as well. Then is there any way like by which I will be able to perform partitioning and bucketing together? Okay, so what I need to do, if I'm willing to perform partitioning and bucketization together, so just have a look. The next topic, what it will be, bucketization with partitioning.
Okay, Ashok, what is the benefit of bucketization over partition?
Both of these two are going to divide the data into smaller chunks. Okay, now now just have a look over here onto the data set itself. We are having this particular data. Now, based upon this particular column, that is the product ID, you can do the bucketization. That is fine because the cardinality is high.
Okay,
Now,
means on the basis of the cardinality, if we have any column where cardinality is low, then we can go for partition.
hmm, but we can perform together. In one table, we can have partitioning and bucketing together in order to to drill, or in order to have the further chunks. You can think in this particular way. Say, say you are having the population data of Haryana, right? And you have done the partitioning based upon the this district, right? Population data of Haryana. Okay, performed partitioning. Just try to understand the logic. Performed partitioning based upon district column. Now, because like you want to get the data with respect to the district and all. Okay. Now, but these particular districts are having a lot of data. Okay. Now you want to do optimization on top of that. You want to do some more optimization. Say you are having the partition in this particular way, like say uh, GGN, okay, SNP, PNP. These are nothing but the partitions. Now, in these particular partitions, what you are having, what you can do, you can have, say, in Gurgaon, that is the GGN partition, say, that is having uh, 10 lakh records, 10 lakhs records. But what you want, you want to minimize this scanning, because this will be having the single file. These 10 records will be available in the single file, say. Or like if we are having multiple files, but we need to scan all of those particular files. So what you can do, or basically like it will be in one file only. The main thing is that it will be in one file. So what you are going to do, you further divide these particular records into different files. Say GGN will have the buckets in this particular way. Say you have done the bucketization, say 2 lakhs in one bucket, file 1, or you can say bucket 0, 1, 2, 3, 4. Okay, so we are having 5 buckets. So previously you were scanning 10 lakh of records because you have done the partitioning only, but now you have implemented the bucketization as well, and you are having 5 buckets. So each bucket will be having 2 lakh records, almost 2 lakh records. Okay, so the scanning has been reduced to one fifth. Previously we were scanning all 10 lakh of records, but at this moment, if we want to have something like from bucket 0, then this much of data will be scanned. Rest 8 lakh records will not be scanned. So this is the benefit once we are implementing partitioning and bucketization together. Clear, Pankaj?
Yes, yes, Ashok.
Is it good with everyone? The concept why we need to perform
Yeah,
partitioning and bucketing together.
concept is clear. Ashok, one thing, can we see it practically for bucketization, like how it is scanning
Yes, yes,
the
yes.
record? Okay,
Yes, yes, we are going to implement. No need to worry. We are going to implement
fine,
bucketization
fine.
with partitioning. Partitioning and bucketization together. So steps, what are the steps, different steps involved? Steps involved, we will be moving with 5 steps only. So let me copy these particular steps, and we need to just perform a little bit change. So creation of partition and bucketed table, and partitioned and bucketed table, partition and bucketed table. Then loading the data from non-bucketed to the partition. Let me mention this, the normal table, normal table, from normal table to partition and bucketed table, and then scan the data from partition and bucketed table. So these are the 5 steps that we are going to implement in order to get the understanding about partitioning and bucketing together. Okay, so fine so far. Hmm. Okay, so we will move with this particular table only. So this is nothing but the normal table. Okay, non bucket product. So we will move with this particular table only, and on top of this particular table we will be going to have, so let me copy these particular 2 steps, and these are like required over here as well. So creation of non bucket table or normal table, what I can say, normal table, normal table, and then loading the data into the normal table, normal table. And let me try to give a name, say normal normal table, normal products, and load the data into the normal products table. Okay, so it's just very simple, like we have implemented it as well in the previous example. So I'm just changing the name of the table to the normal products, and then I'm moving the records. Fine. So that is perfectly fine. Now what I'm going to do, I'm going to create the partition and bucketed table. So that is the step number 3. Creation of partition and bucketed table. Let me copy this and paste it over here. Okay, or let me copy this one. Okay, so I'm going to copy this. That is the way how to create a bucketed table. So create table PB, that is partition bucket products, PB buckets, partition and bucket products, PB products, that is partition and bucketing together. Product ID, this one, name, this one, cost double, and category. Now what I want to do, I want to do the partitioning based upon category. I want to do the partitioning based upon category. So what is the change that I need to implement over here if I want to perform the partitioning based upon category?
Partitioned by
Partition, partition by
category string.
category.
And it will come out from here.
Come out of from
Ye-
here.
Yes. So that is a little bit change once we are going to implement the partition. Once we are going to apply the partition clause. Clause ti partition by category, and that is of string type, and clustered by product ID into, let me mention, say 2 buckets, row format delimited. perfectly fine. And let me copy and paste it over here. Okay, so this is the table which is having partitioning and bucketization together. Now what I want to do, I want to insert the records into this particular table from the normal table. So this is the command. Or let me mention in a different way. Insert into products, PB products, that is partition and bucket table, and that is having the partitioning. Partition based on what category? Partition category, and select star from where? The products normal, normal products, normal products. Okay, perfect. Insert into PB products, partition category, and select from the select star from the normal products. Let me try to copy and paste it over here. Then we will discuss what is going to happen. Okay, so basically, what is happening over here? First, it is going to perform the partitioning. What will happen? It is going to do the so this is the data set, and let me copy and paste it over here. So try to understand it. Okay, so this is the data what we are having. Say we are going to have this particular bucket, this particular partition. So we are having this particular partition, mobile. So we will be having this particular category, and we will be having the partition based upon mobile now. So inside mobile, what will happen? It is going to apply. It is going to divide these particular records into two buckets. Two buckets. So two, one modulus division two. So it will be moving to say bucket uh,
Bucket 1.
bucket one. No. Let me try to get so modulus division how it will work over here. Just a minute. PB products. Okay, and mobile and mobiles. Okay, so mobile and mobiles are there. Okay, mobiles. So over here we will be having in each category we will be having two buckets. We will be having two buckets based upon the distribution of the records. And let me try to see. Say mobile. So mobile 1 and 2. So let me check what is the data. So I think zero record. That is as per my expectation. Hmm. Perfect. And it will be having two records. Hmm. Two records. Perfect. Hmm. Then we will be having mobiles, and it will be having two buckets. One bucket will be blank, and one bucket will be having one record. So this one having one record. I will explain it. No need to
Okay,
worry. And
Ashok, how this modulus will work if we bucketize our data on the basis of a column which is non-numeric?
okay, so the main thing is that like try to implement the partitioning where like the data is the numerical one only. Okay, try to implement the
So means
bucketization.
if I want to bucketize it on the basis of this name, then we cannot do.
You can do, but that will have certain challenges. You can do, that will have challenges. Okay, it is recommended like inside the best practices, it is recommended try to perform the partition bucketization based on the numerical column. Okay, you can
Okay.
do. Okay, even like once we will be moving with the Spark, PySpark. So, and friends, one more thing, whatever we are learning over here, partitioning, bucketing, each and everything that will be applicable with respect to the PySpark as well. A little bit change is there, but the concept will remain same. We will be implementing these particular things inside the PySpark as well. The same concept will remain same, but implementation wise a little bit change is there. Okay, so what has happened? The modulus division is working over there as well. So if it our bad luck, say we have taken two buckets and two buckets. So this is the category. This is say, let me mention mobile only. So these are the record in this particular category, and we are having two buckets. Bucket 0 and bucket 1. So with respect to our modulus division, that is the function which is going to decide which record is moving to which bucket. So 1, 3 and 5, all of these particular records will move to bucket 1, and bucket 0 will be blank. This is our bad luck because we are having less amount of data, and it has been categorized like mobile is getting this much of record. Let me try to toy let me pick fashion. So probably fashion will provide a certain so we are having the data. Fashion is having two records. So one record is moving to bucket number 1, and second is 8 will be onto the 0 bucket. Just try to have a look onto the fashion category. Category fashion. So fashion is having two buckets, and what I have mentioned, 8 will be there into the 0th bucket. Let me open the 0th bucket, download, save, and open. So 8 is onto the 0th bucket, and 7, this particular record, 7, it will be in the first bucket. Just have a look. 7, it will be in first bucket. So 7 is it is in the first bucket, right? Okay. So in this particular way, like say if we are having partitioning, so that is fine. Now we have done the partitioning based upon category, but we further divided the data based upon the product ID, and we have implemented it into two buckets. So the respective record is moving into in a particular bucket based upon the modulus division functionality, which is the system defined function in order to move a particular record into a particular bucket. So which record is moving to which bucket, that is decided by the modulus division internal function. Fine. And we are able to get the understanding what is the need of partitioning and bucketization together. Like we are able to have the further you can say distribution of the record or division, like dividing the data into the smaller chunks, and it is divided into the two stages. First one is based on the category, and second one is based on the product ID. Now what we are going to see, partitioning and bucketing together. That we have seen. Another aspect, what we can think, can we have like the partitioning based upon two or more columns? We have done the partitioning over here based upon the single column only. And if I want to have the partitioning based upon multiple columns, then how I will be able to implement, right? What is the need? So is it feasible one? First of all, like that is feasible. Like we can do the partitioning based upon multiple columns, right? We can do the partitioning based upon the multiple columns, but at this moment you need to keep the hierarchy in your mind, like before implementing the the partitioning and all. Why I am saying, because it might be possible, say you are having the population data. So population data of, say, India, and it is having, say, it is having state information, then it is having, say, district information, and say Aadhaar number. Okay, so this is the hierarchy. So once you are going to do, or once you are going to implement the partitioning based upon multiple columns, so you need to keep this particular hierarchy in your mind. Like district, like is inside the state partition, but state, like, can be, you can create state inside the district, but that will not make any sense. You will not be able to get the benefit, right? Are you able to visualize, friends? Hierarchy,
Yes, Ashok. Yes, yes.
the folder structure. Okay, so district can be inside the state, but if you are implementing state inside district, then it will disturb the amount of scanning and all, and you will not be able to get the desired outcome. And that is coming with respect to the understanding about your data set. Say you are having the data of hmm, hmm, okay, you are having the data of different RNCs, and RNCs are having lack information, and lack further having the site information. Now if you are going to, say, create lacks inside RNC, that is perfectly fine, you will be able to get the outcome. But if you are having the lack first, and then you are going to create the partitioning based upon RNC, and then further you are having sites, so it will disturb the hierarchy, and you will not be able to get the supposed outcome, right? Is it fine with everyone?
Yes, Ashok.
Yes,
Yes,
Ashok.
Ashok.
Perfect. So you need to have the understanding about the hierarchy in order to implement the partitioning based upon the multiple columns. So let me mention that particular example as well, lac and say sites. Okay, so you can do the bucketization based upon sites, and you can do the partitioning based upon RNC and lac. Perfectly fine. So let me try to check the data set. Hmm. I just need to check the data set. Hmm. State, city. Huh. So what we are able to see, this is the say population data, or what I can say orders data, and in this particular orders data, what we are having: order ID, customer ID, product ID, price, then what we are having say zip code, and then what we are having the country information, and this is nothing but the state information. Okay, city, what I can say. So we are having country and we are having state or city. Okay, now what we can do, we can do the partitioning based upon these two columns. Like first we will be having the partition based upon state will be having city or state. Okay, country will be having the city or state, the second partition, and we can do the bucketization based upon say product ID. Over here, like O1, O2, O3, this is nothing but the order ID. Yeah. We can do uh, the bucketization based upon this particular column, that is of string type, but uh, like once we have implemented in this particular way, it has thrown certain issues. Okay, like we are not able to get the outcome because the modulus division function, like how it is going to decide. So either like we need to write down the custom function in order to move these particular records in a particular bucket, right? So what I used to say, like try to implement the bucketization with respect to the numerical column, and that will make a lot of sense, right? Okay, so what I can do, I can take this particular data and I can proceed with partitioning, or are we having any other data set? The good one. Okay, this is settle, canned, bananas, apple, no. Groceries, new products we have done, rank data set. uh Let me check some other data sets. uh, I'm looking for a big file. So if we are having a data set that is having quite good amount of records, then we will proceed further with that particular data. Employee table. Hmm. Hmm. Car transactions. Okay, so we are having 2G BBH report. Probably you will like this. Okay, right? So we are having this particular BBH report, and we are having certain BSc. We are having the sites. So this is fine. This is fine. Huh. Okay, so although like that will not be the correct one, huh? Okay, so we will take these two columns in order to perform the partitioning, and we will take this particular serial number in order to perform the bucketization, huh? Right? Right? But
Yes, yes. But count of sites, I think
count
it will be high.
like so over here at the first go, what we will be having, we will be
Or we
having
can reduce the site count, like we can take limited data set.
so we will be having this much of buckets, huh? Oh sorry, partition in the first go, like we will be having 15 partitions, huh? 15 partitions, that is fine. In each partition, let me try to copy this one. So we will be having another partition, one partition, and in this particular partition we will be having say two buckets, huh? So okay, so we can implement, we can implement this one, huh? The main thing is the main issue when it will come, let me show you. So with respect to this particular, okay, so in this particular, in these particular BSCs, we will be having high number of partitions, huh? So let me try to copy this one, and further what I can do, it will have 160 partition, at the max, okay. So first, like we will be having this particular partition, say JEB, JD, I don't know, like, so this is say one RNC or BSC. In this particular BSC or RNC, we will be having this much of partition, and then in these particular partitions, we will be having three records or two records. So like we can implement, you just need to understand the concept, okay. From the concept perspective we will be able to implement, although like the movement of records or the number of partition all that particular thing, uh, we can check with respect to the data set, so what we are able to get over here, this particular JEBJD that will have high number of you can say partitions, like almost 160 partition will be available over here. In the same fashion, almost 200 partition will be available over here in this particular data set, okay, and almost 200 available in this particular BSC, yeah. Okay, so let's, the main thing what we need to understand, like how to implement partition inside the partition, folder inside the folder, right? That is the main thing that we need to understand, right?
Yes, yes, Ashok.
Okay, so what I'm going to do, I'm going to remove this particular column, okay, because we need to define, we are going to define the schema, and I'm going to save it as CSV file to gbph underscore new share folder, okay. And let me try to copy this one, okay. So create, so steps will remain same. Okay, it will be having 5 steps: creation of table, creation of what you can say, how to apply partitioning based upon 2 columns with bucketization. Okay, this is the agenda what we are trying to implement, and these are the steps what we need to take, steps involved, and we are going to move with the same steps. So creation of a partition, creation of a table with 2 partition, creation of a table where we are implementing partition based upon 2 columns and bucketization based upon single column, although like we are going to implement bucketization with single column only. Okay, we used to implement bucketization with single column only. Like what I used to say, folder can have files, but files can't have files, huh? Right? Right?
Right, Ashok. Okay.
Yes, yes, Ashok.
Okay, so normal table, so creation of normal table, huh? So create table, say bbh normal, huh? And serial number that is of integer type, date is of same, let me take the string type only. Okay, bsc name, bsc name and site, because we are going to implement the partitioning, so it will not be the part of this particular definition, right? Fine so far,
Yes, Ashok.
Yes, yes.
string, then double, drop rate double. Okay, then partition by what, partition by based upon bsc, that is of say string type, and then 2g site name that is of say string type. Fine, and then clustered by what,
Serial number.
let me copy this one, serial number that is of integer type, serial number into what, into 2 buckets, row format delimited, fields terminated by comma, that is the csv file. Okay, so so this is not the normal table, this is the partition table, huh? First we need to create the normal table, huh? Right? So creation of normal table, normal. So this BSc name and all, it will be available over here, right? This is the normal table what we are going to create, and we need to remove this. Fine, this is the normal table.
Yes, yes, Ashok.
Okay, so I have created the partition table, partition and bucket table. So let me paste it over here, show tables, and that is nothing bbh normal, and describe bbh normal. So I just want to see the schema: serial number, date, bsc name, 2g site name, 2g cell name, sdch rate, or drop call rate. So this is the schema what we are able to see with respect to the table what we have created. Now the next step is what we need to load the data into the normal table, non bucketed to say normal table, normal table. So in order to load, what we are having, load data local in path, data local in path, and we just need to mention into table, what 2g normal, bbs normal, sorry, 2g normal. Okay, so we need to copy the path, so this is the table, and this is the file. Things are looking fine. Let me copy the data and load into the bbh normal table. Okay, so select star from bbh normal limit 10. Okay, and just have a look, like we are able to see the data. Okay, so we are able to see the data, like certain IDs are there, date, then BSc name, then site name, cell name, drop call rate, and SDCH, and this is drop call rate. Perfectly fine. Now what we need to do, we need to create a table that is partitioned based upon the two columns, and bucketed based upon the single column, single single column. Okay, column. Okay, so these are certain typos, and what we need to do, bbh say 2 pb, that is two partition and one bucket, bbh 2 pb, and let me create this one as well, copy and paste it over here. Perfectly fine. And what I need to do, I just need to insert the data into this particular table from the normal table. So insert into 2pb, bbs underscore 2pb, and that is partition based upon what, Partition based upon what? BSc, and the second column is to the site name. Okay, perfectly fine. Looking good.
Yes, Ashok.
Okay, and normal instead of normal, I'm going to load the data from BBH normal. BBH normal. Huh. Okay, and this is nothing but the step number 4. And let me copy and paste it over here. Okay, it will take couple of minutes in order to have the execution, but like concept wise we are okay, like we are able to get the understanding, the partitioning, bucketing, how to create multiple partitions, multiple partitions like based on the multiple columns, how to create partition with bucketization. So we are able to get the understanding. So what you need to do, you can take it as an assignment. Try to have your CSV file, certain CSV files, and try to apply the partitioning and bucketization onto top of that particular data, and then like implement it into the different ways, like with bucketization only, with partition only, partition and bucketization together, partition based upon the two columns. Try to implement in that particular way, right? So at that moment you will be able to get the complete understanding. Like if you are moving with certain data set of your own and try to optimize or try to minimize the scanning, then you will be able to get each and everything. It will take couple of minutes, because it is going to to perform a lot of things, like it is going to create partition based upon the BSC, then inside the BSC it is going to create the partition based upon the sites, then inside site it is going to do the bucketization. Okay, it is going to create two buckets, okay, it is having two reducers, so one mapper, two reducer. So reducers are completed, then bash 32 BSC name, just have a look. BSC equal to 0, site name is does not exist. 0 is not existing. Fails as DFS, that is going to like do, it is going to perform the implementation and all. Let me try to check it onto the SDFS side. Okay, so what has happened? BSC name, it shouldn't be like this, no, 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 no. It shouldn't be implemented like this, Mm-hmm. It is like we just need to check. BSc name is this one only. Okay, so what we are able to see, the implementation perspective, like it is performing the partitioning based upon two columns. Let me try to show you. Okay, so say we are having first the partitioning based upon the BSc. Yeah? Inside BSc, we are having another partitions. These are nothing but the folders. Inside the folder, what we are having? We are having two buckets. So from implementation perspective, it is fine. But from the data perspective, like BSc, it can't be 0.0.1. The site name, it can't be 0.0. So from the data perspective, it is not correct. We need to validate that particular thing. So what I can do, I can give this particular data set with you all and try to implement it correctly. Right? You are having the understanding like how to do the partitioning and bucketization, partitioning based upon two columns, but it must be implemented in a correct way. Okay, it must be implemented in a correct way. You need to do the R&D, and you need to like get the BSc name over here and site name over here inside of point 1 and point 0. Are you able to get? Okay, so let me share this particular data set. The main thing is like you must have the understanding how to do this particular implementation. So implementation wise, it is fine, but the outcome is not correct. So you need to check, you need to validate, you need to do the change based upon the data set. Might be like you need to copy, you need to create certain data, say manually. Probably like it is not going to pick these particular records in a proper way, and because of that, like it is picking, or it might be possible you need to change certain data type and all. So you need to perform the R&D, my friends, so that you can have the exact output as per your expectation. Like that is BSc name should be like this, site name should be like this, and then the bucketization based upon the serial number. Right? So you need to do that particular thing as an assignment. I will share this particular data set with you all. Okay, it will be the query will run, and we will be able to get the outcome, but that is not correct. Right? Fine. So try to do it by yourself. Try to implement that particular thing. Pankaj, Gaurav,
Sure, sure, sure,
Mukesh,
Gaurav.
Right, right.
Naresh, Rohit.
Yeah, right,
Right?
right, right.
Okay.
Sure,
Like
Ashok.
implementation wise, we are able to get the partition based upon the two columns, and bucketization based upon the single column, but that is not correct. Output is not correct. We must have the partition outcome based upon this like site name and the cell name, it must came from here. Might be like there, we need to change certain data type and all. Might be we need to, what you can do, you can copy this particular data, or you can create certain manual records. Each and everything is fine, but you need to get the outcome in the required format, in the required way, right? So that particular thing you can take an assignment, and this is all for the day. What I want to cover, I have covered it, and from the next session onwards we will be having focus onto the second kind of optimization, that is like uh, implement the optimization while fetching the data. This is during creation of the tables, the optimization what we are implementing over here. Now the next one, what it will be, once we are having the tables, but we are trying to fetch the data from those particular tables, okay. So once we are going to perform certain queries and all, so at that moment we are going to apply certain optimization that we will see, okay, how to do or how to implement that particular optimization. If you are having certain queries, then you can ask, or we can drop the session, we can conclude the session. Pankaj, Rohit, Gaurav, Vikas,
Yeah,
Mukesh,
fine,
Naresh, and
fine,
No
Fine,
queries.
fine
okay,
so far.
fine. Okay.
okay, okay. Let me stop recording.